Well, my whole job when I'm working a crime scene is to document a scene to where I can take the jury back to that scene. I take tons of video and photographs. On a typical scene, I'll take hundreds of photographs. Why? Well, because there are 12 people at the end of this case that are going to make the most difficult decision of the entire case. I have to be able to take them back and show them what I saw. What better way to do that than using virtual reality? So we're going to talk today about probably my favorite topic, and that is the future. But in order to understand the future, we got to understand what we're talking about, and we got to understand a little bit of the past. So what's forensic science, right? We watch TV. What do y'all think? This is interactive, too. What do y'all think forensic science is? So yeah, it's the application of science to understand things that happen in a criminal investigation, or even really a civil investigation. Forensic is Latin forensis, meaning within a public forum, and it's the scientific application within a public forum, and that public forum being court. So civil court, criminal court, it's just science. Oh, see, this is going to drive me crazy because I'm going to have to talk like this, and welcome to the afternoon with Zach. We're going to talk about science, right? So yeah, that's what forensic science is. It is just the scientific application of various disciplines for court needs. So to understand the future, let's jump in our DeLorean and go back to the past. How old is forensic science? Well, pretty cool. Back in the 1970s, in an area, province of Qin in China, we uncovered these bamboo shoots or these bamboo slips that were actually death investigation recordings from 266 BC. And what's neat about that is within those records, those are actual court cases from 266 BC, is they cite, so this is an excerpt over here on the side, they cite some of the same descriptions that we use today, where they're talking about patterns of injury or bloodstain patterns or shoe impressions. They're using same observations that we use today within the same context of criminal investigations to understand deaths. So that's pretty neat. And we can then kind of fast forward to the 2nd century for Rome. And in Rome, the Roman jurist Quintilian, there's a really famous case of a father who was murdered. And it was initially the mother was who was suspected of committing the murder, but it was actually the blind son. And the blind son, and the way that they figured it out, was bloody handprints on the wall. So we're using bloodstain pattern analysis in the 2nd century, once again, to understand criminal context. So then we can kind of fast forward to 1235. There's another Chinese text called The Washing Away of Wrongs. And this was the first forensic pathology text, meaning that they would understand anatomy, an anatomy within the context of understanding what caused death. So this was actually the first textbook to help medical doctors understand the process to take autopsies. So then we go from 1235. There's a little bit of a dark age period until we get to the 19th century. And in the 19th century, we really see forensic science explode, especially around mid-19th century. Forensic medicine is taking off with fingerprint analysis, bloodstain pattern analysis. You've got Sir Francis Galton. He's one of the biggest pioneers in fingerprint analysis. Dr. Edward Petrowski, he's a Polish guy who was a researcher in bloodstain pattern analysis. He, unfortunately, and I do not endorse this, he would use mallets and rabbits to understand bloodstain patterns and how bloodstain patterns were created. I do not endorse beating rabbits because it's duck season. And then we'll move on to Dr. Edmond Lacard. And Dr. Edmond Lacard is really one of the forefathers of modern-day forensic science. He was a 19th century French criminologist, and he created the first crime lab, the first modern-day crime lab. And really kind of sets forward into motion something that we live by, and that's called the Card's theory of exchange. And Lacar's theory of exchange simply states that with an interaction between two items, there's going to be an exchange of materials. So as you walked in today, on the bottom of your shoes, there may be hair or soils from outside. Or for me, I've got 2 dogs, I've got a kid. There is no doubt that I've got some hair on the bottom of my shoes. And I'm tracking that inside, and I may deposit it on the ground. If there's soil or materials on the bottom of the floor, I may pick that up in the treads of my shoes. There's that exchange of materials. And that's what we're doing in forensic science, is we're trying to understand those relationships between our environments and our peoples. So, forensic science today. We do a lot of really cool things today. So, DNA being obviously one of the biggest ones. Sir Alec Jeffreys is the one who kind of pioneered modern forensic use of DNA in the 80s and being able to do DNA profiling. It has obviously today evolved to where then I would need a large quantity of bodily fluid, so like a gauze worth of blood to be able to type and profile that. Today, I don't even need to be able to see what I'm swabbing, as we have a level of precision and sensitivity within our testing that we are getting trace DNA. So as you walk in and you touch something, there's a very real possibility that you're leaving behind some type of genetic profile. And we can do some really cool stuff with that nowadays. What's neat about that is the problem is that if I touch this and then he touches it and then you touch it, is we now have multiple profiles on here, right? It's called a DNA mixture. And that can be really difficult when you're doing a criminal investigation and you're trying to sift all of these alleles. Well, with contemporary use, we can actually sort 7 different profiles from one mixture. And that kind of ties in right into genetic genealogy. Anybody ever heard of the Golden State Killer? Yeah? It was solved with genetic genealogy, right? If you'll remember around, 2018, 2019, somewhere around there, the whole concept of being able to use Ancestry.com. Anybody swabbed your mouth and sent it in because you wanted to find out how much of a Viking you were or if you were from Italy? I wanted to be able to prove that I was truly a Viking, right? Well, yeah, when you submit your DNA to those different organizations, those different companies, they go into a DNA database, and what they're doing is they're comparing your genetic profiles. Well, that's how we caught the Golden State Killer, is we were able to take an unknown crime scene sample and start comparing it against that very large database. And that brings up a huge, interesting ethical question that we'll kind of talk about at the end about privacy and all that kind of stuff, because it's only going to become compounded as we progress into the technological age that we are. So yeah, genetic genealogy, that's being able to basically look at a large genetic tree and parts of your DNA profile to narrow down our pool for a bad guy. So I might be able to say, these alleles are consistent with this person maybe being a second cousin, so we need to look down this branch of this particular family. And more, it's really being helpful in cold case investigations. So something that I have a huge interest in as I work cold case investigations. What we talk about today with technology is something called NGI. So anybody ever heard the term AFIS? So AFIS was the Automated Fingerprint Identification System. It is no longer that. It changed in around 2010, 2012 to NGI, the Next Generation Interface. It's the national database that we use for fingerprints. So if you have ever had your fingerprints taken for an employment or for a weapons license, or you were arrested, no one in here, I'm sure, but all of those fingerprints get put into one repository, and that's NGI. The other component of that is CODIS. CODIS is the Combined DNA Index System, and this is the national database for DNA. This is where it's comprised of 3 registries, and that is the crime scene registry. So these are all unknown crime scene samples. So I swab something at a crime scene, I submit it, it gets entered into CODIS, and that's the repository that's going to, so we don't know who they belong to, but that is being run against the offender registry. And this is where if you were convicted of specific felonies or crimes, that's where your DNA is going to be submitted into that registry. And then we have a missing persons registry where samples from missing persons are submitted for unidentified human remains and stuff like that. Yes, ma'am. Ooh, which one do I use more often, NGI or CODIS? I use NGI more often, mainly because fingerprints are kind of our bread and butter, and that we collect a ton of fingerprints in investigations, and I can run that a lot quicker. It usually takes me about an hour to run a fingerprint through NGI, whereas with a DNA submission, I have to send it down to the state, and it takes much longer than an hour to be able to run DNA samples. So a few months. So NGI all day long. So what's cool about NGI and CODIS is that it's just a computer network, right? So I think it's a good point to kind of drive while we're here, is it's just a bunch of computers holding information, talking to each other that I have access to. And that's all on its own very neat. Yeah, so it's a special file format. So the way that we submit a fingerprint is I will either scan or upload a photograph into the NGI user side, and then I'm going to go through that fingerprint and I'm going to mark individual points, right? And so the best way I can kind of describe it is NGI doesn't submit the picture all marked up. What NGI is submitting is the spatial relationships of those. So if you think of a constellation where we draw, pictures from stars, that's exactly what I'm doing. Is I'm submitting the fingerprints constellation to be compared against all of the other constellations. So it saves on file size and a bunch of. It's just a lot quicker for the algorithm to work its way through because it's just a puzzle piece, right? Yeah, so the question is do your fingerprints change as you cut them, or does it regrow back? The answer is it depends. The answer is it depends on the level of damage to the skin, right? So you can cut your finger, and those unique marks are going to grow back, depending on how deep that cut is, right? I believe it's after the 4th layer of dermis is where we actually start losing material. Anybody know the name John Dillinger? Right, so John Dillinger was a good old-fashioned 1930s and 40s mobster gangster who was an outlaw. He was charming. He was a legend. And he tried altering his fingerprints with acid because he didn't want the FBI to catch him based off of his fingerprints. Well, joke's on you, John, is because you just made your fingerprints even more unique. Those scar patterns end up creating a unique pattern of their own. So now we see it today with drug cartels doing the exact same thing, is through surgery or a variety of other methodologies. It's still, you can try and change your fingerprints, but it's not going to do anything. It's going to make it even more unique. Yeah. One of the other kind of cool technological aspects that we use today is LiDAR, is our ability to map a scene, a crime scene, right? So we use 3D laser scanning. I can put it up. Basically, it looks like a big tripod with a head on it, and it shoots a laser out, and it scans, and it's everything that laser touches is a measurement. And I'm creating a point cloud to do a 3D model of this room. So in one scan that's about 2 minutes long, I'm collecting about 47 to 50 million points of measurement. That's super cool. And I'll show you kind of an example of what it looks like. But we can also do something called photogrammetry. So a lot of times here in Roswell, we may have a serious wreck. We use drones to map that scene. We can put a drone up, and that drone is going to take hundreds of pictures of that particular wreck scene. We can merge all those back together. And because our program knows the degree that camera was oriented, as well as the distance, it's just trigonometry, as we can start using photogrammetry to merge all that data together and, again, create a 3D model of a wreck scene, and that only takes us about 10 minutes to run a flight. So, what's the future of forensic science look like? I am an eternal optimist, very much like Doctor Who, and I think that it is very cool. I'm artificial intelligence, I am totally 100% an AI fanboy. I love how we can integrate technology in our everyday life. Anybody use AI like intentionally every day? ChatGPT? So I have an app on my phone, the OpenAI app, and I call him Artie. Because that's what he told me to call him. He may be influencing me a lot more than I realize. But yeah, I have incorporated it into my workflow because it makes life easier. right? And that's the whole concept of technology, is that we want to make life easier so that we can enjoy more aspects of our life, right? So how does that incorporate into forensic science? There's a really cool paper that was editorial that came out in 2019 in the Journal of Forensic Science. And one of the authors is a guy named Etel Douar. He's a professor out of University of London College. And he basically put forward the concept of being able to create an AI model for crime scene reconstruction. Anybody know computer modeling for like air flight simulations? So anybody ever done one of those computer games where you're flying an airplane, a big 747, right? And it's taking into account all the different variables of your environment, right? Is the wind speed. How is that wind speed affecting your particular degree of orientation of the plane? How is the temperature affecting your lift, right, for the Bernoulli effect? All these independent variables have some kind of influence on the overall product. Well, can we apply that same concept in crime scenes? Can I input certain information into a crime scene reconstruction model to say, hey, I found a fingerprint here that had an orientation of going up. And then over here, I found a bullet case, I had a dead body over here, and I had some bloodstains over here. What is the most likely hypothesis of all of that information? And then it provide a statistical printout, right? I say printout because that's what I think of, right? I'm sure there's a printer in here somewhere that is just like that. But that's what it is in my head, right? Is it provides a response to, based off of the available information, the most likely hypothesis. This is called likelihood ratio, that one hypothesis is more likely to have occurred than the alternate. So that is one place that I see AI really being able to be utilized. Yes, ma'am. So I would use the hypothesis that has the most accurate information. It would be the one that I would put forward, right? So it is not, so I'm a crime scene reconstructionist. This is something I do pretty much by hand right now and based off of interpretation. And to a jury, I would say, there's this concept of, well, what's your degree of scientific certainty, right? Well, it's a made-up term. I have no way to gauge a degree of scientific certainty. What is scientific certainty? I can just tell a jury, based off of the available information, this is a probable scenario that could have occurred. Not to exclude other ones, right? The defense or the prosecution can put forward, well, is this possible? Based off of the available information, yes or no. So this would be able to provide just a better number. That's the difficult thing that we have right now in certain aspects of forensic science, is being able to apply a statistical number to it. Is how do I apply a statistical degree of confidence to my fingerprint examination? Well, I'd have to know the number of fingerprints in the entire world. And comparing that data, there is no ground truth, hard data for me to compare that against. So it's an interpretation. This is another really cool thing. Anybody use Pokemon Go or some kind of augmented reality with your phone and you see a dancing unicorn on a table or anything like that? I've seen it on commercials, and so I haven't tried it. And I know that when I worked patrol, Pokemon Go was kind of a big thing. And so often at 4 in the morning, I worked nights a whole lot. So I would often kind of roll up on a suspicious car at a cemetery at 4 in the morning. I'm thinking, oh yeah, I got me something good here. And it's some dork that's playing Pokemon Go. I can say that because I am equally a dork. It takes one to know one. But yes, but this concept of Pokemon Go, of being able to use your phone or other types of device to see your environment and then have a computer-generated image within that environment, right? Augmented reality. Or I guess this is really kind of more virtual reality. The new Apple lenses, whatever those goggle things are, right? I love looking at all the TikTok and Instagram videos of people walking around. That's eventually what we're going to look like, right? Is it's going to be just like, what's the Wall-E, right? We're all going to be in chairs with goggles on, and we'll be living in our virtual world. But how can we incorporate that within forensic science? Well, my whole job when I'm working a crime scene is to document a scene to where I can take the jury back to that scene. I take tons of video and photographs. On a typical scene, I'll take hundreds of photographs. Why? Well, because there are 12 people at the end of this case that are going to make the most difficult decision of the entire case. I have to be able to take them back and show them what I saw. What better way to do that than using virtual reality? There's actually pilot tests being done out in California of putting Oculus Rift goggles on jurors and being able to walk them through a 3D model. Well, I just told y'all about how I'm creating 3D models of crime scenes. I can now incorporate that 3D model and take my jury, literally put my juror right there in the living room looking at a bloodstain pattern. How cool is that? That's being done now. So some of the problems that we're kind of facing with that, though, is it's causing motion sickness, right? So that that is one thing to try and figure out in a technology that is very novel and at its infancy. So I'll be curious to see how that, because I truly do believe that. Anybody Star Trek nerds in here? Next Generation. I was totally a Jean-Luc Picard kind of guy. But the holodeck. The holodeck was always the one thing that I wanted to be able to utilize most on the Enterprise. Is I wanted to be able to walk into a room and go, computer, take me to the Old West. And then suddenly, just like Jean-Luc Picard, I'm in the Old West. That's super cool. And I think eventually, in a century or so, perhaps that's where we will be in our courtrooms. Because this is what we're doing, right? We're doing complete immersion of that technology for our jurors so that we can take them back. This is currently what I'm able to show jurors. This is that 3D model I told you about. That is millions of points of measurement with color photographs that are overlaid on top of those measurements to generate a 3D rendering of our particular crime scene. What's great about this technology is not only am I able to provide a diagram or a model of that scene, I can start extracting measurements from here. So we can see that I've got some flight path rods, some bullet trajectory rods in the hood of that car. I can calculate the angles within the computer program. I can start bringing back where the shooter most likely was within the computer program with a standard deviation applied and calculated. Over there, bloodstain patterns on the wall. I can calculate where in three-dimensional space those bloodstains originated from within the computer program. All to a degree of scientific certainty for a term that doesn't actually exist. Yeah. Yeah, so that's an effect that is... it's wowing the juror, right? Because if I show you, like I can show you this and it can like literally in the grand scheme of a case, it may not matter. Like truly, like I can whiz bang boom you into showing you, look at all the technology that we used in this case, and maybe I'm wrong in that case, right? But because I utilized all these resources, you're inherently going to have a bias to believe me. This was an effect that was really prevalent after a certain show in 2001 called CSI. And we saw what was called the CSI effect. It's a very well-documented effect to where jurors began to expect, well, where are the fingerprints in the case? Where's the DNA in the case? I'm going to tell y'all, I don't always get fingerprints and DNA in every criminal case. And it is actually not that uncommon to not have fingerprints in a case, right? Because as I pick things up, there's inherent motion, right? I'm twisting and I'm turning, I'm distorting those fingerprints. But jurors expect it. And if you don't have it, well, then are you incompetent? Right? And so there's the opposite side of bias. Yes.
I saw this thing recently with the Dominion voting machine.
Yeah, so is there discussion on the emotional impact of this kind of imagery? Yeah. This is a mock scenario. This is not a real case. I intentionally, I forget sometimes that I have certain images in some of my presentations, so I had to make sure I didn't have anything in here. Yes, so there's already, even with still photography today, right, there is precedent where I cannot show any image that would incite the emotion of a juror, right? I can't show a gory picture just to show a gory picture and shock and awe you, right? There has to be some type of actual information that I'm trying to show you within a photograph. Now, don't get me wrong. Some crime scenes are inherently disturbing and gory. just because of what happened within that particular incident. But you can show information in a very tasteful and sensitive manner. Man, y'all have great discussion. All right, so you're going to see this kind of get cranked up in speed a little bit. So 3D printing, that's kind of a cool, novel concept of starting to incorporate being able to, apart from take a jury and immerse them in a digital world, hand them something that actually has texture, right? Being able to replicate and actually print a wound, right? Or some kind of injury that I want them to understand, and I can actually put it in your hands. So that's just one kind of concept behind it. So those demonstrative aids to take into court. Quantum computing. This is... Once quantum computing really takes off, I think that what we're going to see exponentially, just in terms of our civilization, is... I have no idea what the next 20 years looks like because I don't know how this is going to play out. But being able to use quantum computing within forensic science in sensors, right? So being able to process all that data. Like I said, you're talking 50 million points of measurement. Well, now we can process it a lot faster through quantum computing. Being able to take something that would traditionally take us several hours to process, and we're doing it in under 30 seconds. So that's where I see it really taking... having the biggest influence in forensic science is your time that you are saving out on scenes and the amount of data that you are able to actually sift through. Now, take quantum computing, merge it with our artificial intelligence, right? Now we start applying that kind of computer modeling to crime scenes. What can you imagine that would actually look like? Biomolecular research. So I can't tell you right now when a fingerprint was deposited. I can tell you that at some point in the past, somebody touched this. But when did they touch it? Well, there's currently research that is going on to look at literally down to the molecular level of fingerprints. Can we age fingerprints? What can we determine based off of the information within that fingerprint that we collect? Well, right now we can possibly type gender. Did somebody use tobacco? We can start looking at characteristics that we can extrapolate, and that's ultimately what we're kind of marching further and further towards, is truly exploitation of information from one particular item of evidence. Using light, so this is something we do today that we have here in Roswell, full spectrum imaging, so using everything from the ultraviolet spectrum all the way up into infrared, and being able to image things that the human eye can't see, such as gunshot patterns, so gunshot residue on dark clothing, can't see it with the naked eye. When I use infrared lighting and special filters, I can see it. I can start understanding how far away, based off of that pattern, was the firearm to the target. Same thing with bloodstain patterns, being able to image and look at bloodstain patterns on dark clothing, as well as fingerprints, and using deep ultraviolet light to image fingerprints before I ever even develop them with powder or chemicals. So looking at the naked fingerprint before I ever even disturb it. Where do I ultimately see this all going? This. Going back to Star Trek, my tricorder, right, is I have everything all in here. So what's cool, what I haven't told you about, is there's actually a new app. So with iPhone XR, or I think it was 12, it was either XR or 12, they incorporated a LiDAR sensor in here. The same technology that I'm using on my scanner. Well, there's actually an app developed by a good friend of mine in Canada that uses that LiDAR sensor to now scan your scene with your phone. It's super cool. I've already done it a few times and validated it. There's a ton of research on it. And so I can do everything that my $60,000 instrument does in my phone. It's pretty neat. It takes a little bit of time to process, but I can literally scan and create a 3D model of anything I'm out on a scene to. So we're reducing the amount of processing time again. So I have AI built on here, right? I was already talking about ChatGPT and how Artie is telling me all kinds of, hey, Artie, how do I do this? And give me text, right? FLIR, so forward-looking infrared. It's that thermal vision or that infrared vision that we use to see things in the dark. Well, there are now FLIR sensors that I can attach to my phone. So already today, we are starting to incorporate technology more and more on here. This takes pictures that are way better than the pictures that I take with my DSLR camera. My DSLR camera I use for work is 20 megapixels. I think this has 47. So this is already a great crime scene camera, right? I like my DSLR because I can manipulate the manual mode a little bit easier for that light. Yes, sir. Yeah, absolutely. Right. So you do have a focal depth issue that kind of takes place. But for basic scenes, this absolutely works, right? So we're starting to see more and more how we can integrate this all into one. And that's where I ultimately see in 10 years, this will be my main tool that I'll use out on a crime scene. Because I can already measure it, right? I can open up that measuring app and go, what's the distance from there to there? Because it's got all the gyro sensors in here. So it knows the degree at which I'm changing.